Hello, we're Group 7. This is project number 27, and this is our final code review and demo. So we are supposed to be making a plugin that is able to read the project size and the pin count of an Arduino sketch. And based on that information, our plugin recommends a microchip of the most optimized microchip best fit for the project. So far, this is the running code that we have for our application. We have a program that's able to get the file size of a given example sketch. And as you can see here, in our command line, we provided the name of an example sketch, Arduino sketch, and it's able to read the file size of it, 14 kilobytes roughly. So that is our first part of our program. The second part is able to The second part provides a set memory value, and based on that memory value, it compares it to the memory size of other microchips, and it's able to recommend to see the smallest difference, the most optimized difference between the microchips in order to recommend the most optimized microchip. And this is how we were able to make it. So for our first program, we take in an argument, a command line argument, and that is the name of the example file we gave it. It's able to find the file in the same directory, and we pass that as an argument to a function that returns the size of the file. For our second program, we stored the parametrics and the specs of different microchips in the Mega AVR family in a JSON file. As you can see here, this is the memory size of a microchip, and I did the same for the Tiny AVR family, and this is the program. We used an external parser and Loman to parse the JSON to grab the memory values of each microchip. We then used a function to able to compare the set memory value with the different values of the microchips to see the smallest difference, and we use that difference in order to recommend the most optimized microchip. And as you've seen, we have not gotten to that part yet. We were also supposed to combine the two together to just make a single application. We will do that early on for our next sprint. So that is the working program that we have so far. As far as where we are on track for our project, on our project plan, we plan on finishing the MP LabX plugin by mid-March. So what we have so far concerns memory, and we could easily combine the two to make a running memory size. So we are on good progress. And we also have, so for now we are providing set memory sizes as well as example files. Ideally, our program should get any given sketch and grab the memory value from that in order to compare it to other microchips, and as well as attribute the smallest difference to a microchip in order to determine that it is the most optimized microchip for that project. And as I've mentioned, we are going to do that early on next sprint. So this is our project repos that consists of mainly research. For our branch 1, this is the pre-processing documentation we had to show off the process that the sketch goes through. For branch 2, this is a sample code to run on MPLAB X. Branch 3, this is an example sketch to run in the Arduino command line. Branch 4, these are just common Arduino library examples to familiarize ourselves with Arduino. And this is branch 5, where we put the documentation for the AVR GCC research to demonstrate how it interacts with our plugin and how it would interact with plugin in different libraries. Branch 19 is stack-related research for the Arduino stack. Branch 20 concerns Internet of Things project to run on the Arduino. Branch 21 are just more examples, as we will be working with various libraries. Branch 22 is where we committed the initial program to get the file size of an example sketch. Branch 40 provides an example project to run the Arduino Mini. Branch 41 is where we committed the program that compares a memory value with other memory values of microchips, AVR and tiny, mega AVR and tiny AVR. Branch 42 is where we committed a program that recommends Uno or Mega board. It also has our pin count related research. And finally, branch 43 is where we have documentation for comparison between the Atmega 4809 and the 328P. And that is our repository, as well as our running programs for our application. Thank you.